right, so today we're going to continue talking about ratios. And for example, we know that a ratio is two numbers. Okay, for example, something like this, we know that a ratio can represent two different quantities, 2 girls to 3 boys, 2 apples, 3 oranges. We also know that sometimes we can make ratios that are what we would call equivalent. So for example, first number, we know that 2 times 2 is 4. So we would do the same thing to the second. And we would have equivalent ratios. We could say that the ratio of 2 to 3 is equivalent to the ratio of 4 to 6. All right, well, today we're going to actually take these ratios and we're going to work on something called a ratio table. All right, so in our math book, which you don't need to take out right now, we're looking at section 3.3. We see a picture here, and the picture goes with this story. You buy milk that contains 180 calories per 2 cups. You measure 2 cups of the milk for a recipe and pour it into a pitcher. You repeat this 4 more times. Make a table to show the numbers of calories and cups in the pitcher as you add the milk. So I would like for you to go ahead and we're going to make a table in our math notes. So go ahead and open up your math notebook if you haven't already. So here is what my ratio table looks like. I have the label of calories for my first line, and then I have milk for the second. I've put the ratio of 180 calories per 2 cups of milk. And then it says we're going to repeat this another 4 times. So if you could go ahead and make this ratio table for me. All right, so then we're going to go ahead and we're going to continue making equivalent ratios. So we know that, for example, we would double the 2, that's going to be 4. And if I double the 180, that's going to be 360. Okay, so it says we're going to repeat this pattern over and over. So we're going to keep counting by 2s here. So this would be 6, 8, and 10, which means then we're going to come up here and we're going to continue to count by 180. We're going to add 180 each time. So our first one here would be 540. And then if I take 540 and I add another 180, we're going to have 720. And then if we would go ahead and we add 180 one more time, we're going to have 900. So you can see here we have 2 cups of milk is 180 calories. If I double that, I can make an equivalent ratio of 4 to 360, 6 to 540. All of these are considered equivalent ratios. So I kind of showed you how we would write those ratios and how we'd show that they are all equal to each other. They are all equivalent to one another. Now what we're going to do is we're going to do something called a double number line. Double number line. So go ahead and write this down in your notes. If you need to pause your video, please do so. All right, so a double number line. It's self-explanatory, as you can see. I basically have taken 2 number lines, okay, one on top of the next, because we're going to have 2 different quantities. We're going to basically take our table and we're going to share the same information on what we would call a double number line. In order to make a double number line, we have to put our labels. So we're going to go ahead and pop one up here, calories. And of course, then we'll label the bottom one down here, milk. I always like to start my double number line with 0. So these would be 0 right here on the end, 0. And then I'm going to go ahead and put some tally marks. And my tally marks, I'm going to kind of try and evenly distribute them across like so. Okay. And so what we're basically going to say is, for example, I have 0 cups of milk here. If I would do 2 cups of milk, that matches with how many calories? Well, according up to our table up here, it matches with 180. If I would then move up to 4 cups of milk, 360 calories. 6 cups of milk, 540. 8 cups of milk, 720. And 10 cups of milk matches with 900. So I basically have shared this information 2 different ways. I've set up a ratio table and I've also made something called a double number line. So let's go ahead and write over here that we know that this is called a double number line. And then let's put up here that this is called a ratio table. Okay, very good. All right, so what I'd like for you to do is go ahead and make this next ratio table in your notes for me. You will notice I have the titles or descriptions triangles to sides, and then I've made 4 columns here. I'm going to let you go ahead and copy this in your notes. Please pause your video so that you can get this written down. All right, so let's go ahead and figure out here. Let's go ahead and put a 3 right here. I forgot to write that there. So we know that one triangle has 3 sides. So for example, we would know that 2 triangles would have 6 sides. If I have 9 sides, how many triangles would that make? That would make a total of 3 triangles. 4 triangles then would be how many sides? We'd have a total of 12. Now, if you notice, we have some repeated patterns. So we went from here, we added 1 each time. Down here, the repeated pattern was we weren't adding the exact, our 1 this time, we were adding 3. And so from here to here, we added 3. And from here to here, we added 3. All right, so we're going to do another ratio table, and I'm going to show you how the pattern sometimes can change. Once again, if you need to pause the video, please do so. All right, so let's go ahead and make this new ratio table. We're talking about frogs and toads here. Okay, I'll let you get this all written down. All right, so let's go ahead and look here at our frogs and toads. So if you notice, we have frogs 4, toads 6. Now, if you notice, how did I go up here from 4 to 20? Let's look at this and see. Well, in this problem, we took 4 times 5 to get 20. Whatever we do on the top, just like we would do in our proportions in our math morning work, we would do the same down here. So we say 6 times 5 is 30. Now you notice I can't go this way because there's no number here. So let's go. How did I go from 30 to 90? I'm obviously doing multiplication for this table. So I take 30 times 3 to get 90, which means now I have to multiply by 3 up here. 20 times 3 is 60. And if I went from 90 to 180, it looks like I took 90 times 2. So up here, I'm going to do 60 times 2, which would give me 120. Now, once again, you will notice we made all these ratios. These are all ratios that you see in each spot. So for example, this is a ratio right here. This is a ratio. These are all ratios. And I could actually say that all of these ratios, the ratio of 4 to 6 is equivalent to 20 to 30, which is equivalent to 60 to 90, and which is equivalent to 120 to 180. And I could say the same thing about all the ratios up here with the triangles and sides. Okay, let's continue working. All right, so if you would make this ratio table in your notes for me, I'm doing dollars to cents. So for $1, I have 100 cents. How many dollars would make 300 cents, 900, and then I jumped here to 8. So go ahead and copy down my table for me and then see if you can fill in my missing numbers. All right, now there's a couple ways that you could do this. You could actually continue counting like this, 1 to 100, 2 to 200, 3 to 300, 4 to 400, 5 to 500, 6 to 600, 7 to 700, 8 to 800, and 9 to 900. So you could actually continue making the ratio table in order. If you notice, I did not. This way you can find all the information that you need. So what matches with the 300? 3 goes with the 300. 900 cents went with $9, and then 8 went with 800 cents. If you notice, ratio tables do not have to be in the same order and have to go in sequence. I can skip or I can jump around. So for example, if you noticed from here, we took 1 times 3 on the top. Well, whatever we did on the top, remember we have to do on the bottom. In order to go from 3 to 9, I multiplied by 3 again. All right, well, that worked. But if you notice from 9 to 8, I did not multiply by 3. I subtracted 1. And so down here, I'm going to have to subtract, but I'm not subtracting just 1. I'm subtracting 100 because if you remember, the 1 and the 100 was our beginning ratio. Okay, let's practice another table. All right, so here's the next ratio table I'd like for you to go ahead and make in your notes. We have meters and minutes, 3 to 1. And then we have here 2 minutes, 2 meters, and then I have 5/3. So go ahead and make this ratio table for me, please. All right, so sometimes what I'll do is I'll kind of start making this ratio here 3 to 1. And if I would double that, then I'd have 6 to 2, right? And then if I did that again, if I did this side, then I would have here, this would be a 3, be 9 to 3. If you notice, I'm counting by 3s on the top, so this would be 12 to 4 and 15 to 5. And so we'll kind of stop there to kind of give me a basis of where to go to. So 3 meters in 1 minute. If I would double that, that would be 2 minutes, which would be 6 meters. Well, up here I have that I'm only going 2 meters. Well, if you notice, I don't have even a 2 up here on the top. So somehow I'm going to have to decrease this ratio to make it be a 2. Well, since I know that I can go 3 meters in 1 minute, I'm going to have to take this and I'm going to have to divide my 2 meters by these 3 meters into a minute. So I'm going to take this number 2 and I'm going to say it's going to have to be 2/3. It's going to have to be less than a minute. It's going to be 2/3. Now, if I notice here, I've gone here 2/3. Well, this would be 5/3. 5/3. Well, most of us know that 5/3 is top heavy, correct? So if I would do 5 divided by 3 like this, I would get 1 2/3. So if you notice, I'm looking for an answer that's going to actually be somewhere in between 1 2/3. It's going to fall in between these two numbers right here. So it either has to be a 4 or a 5. And the number on the top of this fraction tells me it's going to be a 5. So in 1 minute, I can go 3 meters. In 2 minutes, I can go 6 meters. In 2/3 of a minute, I can go 2 meters. And in 5/3 of a minute, I can go 5 meters. So if we look at our ratio table up here, we multiplied by 2. We did the same thing on the bottom. Then from here, we divided by 3. So we did the same thing on the bottom. We 2 divided by 3, which is 2/3. Up here, if you notice, from 2 to 3, I added 3. And if you remember, for every 3 meters, I do 1 minute. So down here, I had to add that down there. All right. All right, so we're going to try one more ratio table. This ratio table says students to teachers. And for every 24 students, we have 2 teachers. So what happens if I only have 12 students? How many teachers would make an equivalent ratio? What happens if I went from 2 teachers to 4 teachers? How many students would that make to make these equivalent ratios? And then I have 36 students. See if you can complete my ratio table. All right, so if I'm looking, I've gone from my 24 students here to my 12 by cutting it in half, right? So that means I'm going to have to cut this in half, which means I'm going from 2 teachers now to 1. All right, so now I'm going to look here at my ratio table, and I'm going to see how did I go from 2 teachers to 4 teachers. So from 2 teachers to 4 teachers, I multiplied by 2. Well, then that means I have to do the same thing up here on the top. I have to take 24 times 2, which would be 48. All right, so my last one, if you notice, I can't go really from 24 to 36, can I? There's nothing that I can do here. So, but I noticed if I have 1 teacher and 12 students, I'm going to put this as teacher to make my notes here. 2 teacher gave me 24 students. 3 teachers, so I'm counting by 12s. Oh, look at this. 3 teachers would give me 36 students. So I found out my answer. So if you notice, once again, ratio tables do not always have to be in order, but I will tell you that each column is a ratio that's going to be equivalent to the other one. So for example, 24 to 2 is equal to 12 to 1, which is equal to 48 to 4. And then this one is equal to 36 to 3. Some of you might notice if I would reduce 24 and 2, I get 12 to 1. If I would reduce 48 and 4, guess what I get? 12 to 1, because they are all equivalent ratios. All right, so your homework assignment for today is as follows. You're going to open up your textbook to page 126. Okay, page 126. We are going to do numbers 2 through 28 even. 2 through 28 even. Okay. All right. Well, there are lots of teachers in the classroom that can help you as you are working on your homework. Please feel free to ask any questions.